Hi, welcome to this lesson. We're going to be simplifying algebraic expressions, which is something that's very easy if you just remember to follow PEMDAS. It says use the order of operations PEMDAS to simplify algebraic expressions. PEMDAS is an acronym that stands for parentheses, exponents, multiplication, division, addition, and subtraction. So whenever you have an algebraic expression, you first want to simplify the parentheses. Sometimes there may be parentheses that you don't actually see, but they're implied. And I'll give you the main example of when this happens, and we'll see an example here in this video. But if you ever have a fraction where it has some expression in the numerator and another expression in the denominator, there are implied parentheses. So there are invisible parentheses there and here. Those are just implied. For example, it's saying get all of this here and divide it by all of this down here together. Okay. The next operation we would follow is exponents. So if you see something with exponents, which are just those little scripts that go up here, like x to the second power, that power of 2 right there is an exponent. What that means is this 2 tells you how many times you multiply the base to itself. And the base is whatever is down here, whatever is being raised to a power. So this means that you multiply the base of x to itself twice. So it'll be like that. X to the second power means x times x. So then we work with exponents. After that, we multiply and divide, and these are worked from left to right. They're kind of equal. So if you ever see them together, you work them from left to right. Same thing with adding and subtracting. Work these from left to right. So we're going to follow these order of operations when we simplify algebraic expressions. This first sample problem has those invisible parentheses that we were talking about. So it's all of this up here in the numerator being divided by all of this down here in the denominator. So let's work within the parentheses first. X to the second power, I'm going to represent that in one color. So I'll make this one in red. So x to the second power is x times x. X to the fifth power, I'll do that in a different color. I'll make it in blue. That's x to the fifth power, so we multiply that to itself 5 times. And then y to the seventh power, that's y multiplied to itself 7 times. So we'll also do that one in a different color. So far we have expanded the numerator. Let's do the same thing with the denominator. When I say expand, I mean that we're factoring out the numerator. A factor is something that multiplies to something else. For example, these x's, x times x right here, they multiply to be x to the second power right there. So these are the factors of x squared. So we expanded the numerator. Let's also expand the denominator. So this x right here, I'm going to write it in a different color. So that's x times this x to the third power in another color. X to the third power would be x multiplied to itself 3 times. This y to the second power, that's y multiplied to itself twice. And finally, y to the third power, that's y multiplied to itself 3 times. Now we can go ahead and rewrite this so that we've simplified the numerator, and then so that we've simplified the denominator, right? Because we're working within these parentheses right here. So let's first do the numerator, these parentheses up here. So this right here, x multiplied to itself 1, 2, 3, 4, 5, 6, 7 times. That's going to be x to the 7th power. right? That exponent, that power tells you how many times you multiply the base to itself. So that's x multiplied to itself 7 times. In the numerator, these y's here are being multiplied 7 times, so that's y to the 7th. That one I really could have left, but I just wanted you all to see how to expand. Okay, now let's do the denominator. We have here, in the denominator, we have x multiplied to itself 4 times. So that's x to the 4th power. And then we have y multiplied to itself right here 5 times. So that's y to the 5th power. All right, so we've done the p in PEMDAS. So we've simplified the numerator, and then we simplified in these parentheses here, we simplified the denominator as well. Okay. Let's continue to use order of operations to simplify this. So far we have done the parentheses, so we've just done the p. Now let's work with the exponents, so that is the e. Here we already have the exponents. We've kind of worked with those when we were working within the parentheses. So if I show you what we did up here, you'll see that that's exactly what we did. We got this, and we turned it into x to the 4th power right here. Same thing up here, right? We got that, and we turned it into x to the 7th power. So we already worked with our exponents. Now let's continue to use the order of operations. The next one says multiply. Multiply and divide. Remember, those are equivalent, but you work those from left to right. One thing you will notice is that this right here is, although it's helpful, if you know the properties of exponents, which we will do in another video, then you can just, from here you can just get the answer. But if you don't know the properties of exponents, you can still simplify by just doing what we did up here, which is expanding. And since this is simplifying expressions in this video, I'm not going to go into properties of exponents, so we'll just use this right here. Whenever you have a factor in the numerator and another factor in the denominator, you can cancel those factors out. So let's just rewrite what we had up there so that it's a lot cleaner and neater, and then we'll cancel the factors out. And we'll be doing the division part of PEMDAS, right? Because we work the multiplication and division from left to right. So this here says x multiplied to itself 7 times. So I'm going to write x multiplied to itself 7 times. Then I'll write y multiplied to itself 7 times, and so on. I'm just going to expand everything. Okay, and now we can cancel common factors out. Down here I'm going to put a times 1. You will see in a little while why I do that. Anything times 1 remains itself. You can check in a calculator, multiply your lucky number times 1, it'll stay the same. Any number times 1 is itself. Okay, so common means the same. Factor means something that multiplies. So if we have a factor in the numerator and in the denominator that's the same, they're common factors and they can cancel out. So these cancel out, these do, these cancel, these cancel. Then we could cancel these right here. We could cancel these right here. This one here, and this one here. And then we will just rewrite everything that is left over, and that'll be our final answer. Okay, our final answer is x to the 3rd power times y to the 2nd power divided by 1. Remember, anything divided by 1 remains itself. So this stuff divided by 1, it remains itself. So the final answer is x to the 3rd times y squared. This sample problem was really just me trying to show you about common factors, because that's really, really important to know. The next problems are going to be more in depth. So let's go ahead and look at the next ones. This sample problem asks us to get this and divide it by this. So that's what we are going to do. It's actually going to be a lot easier now that we've done the problem before that. Let me show you. I'm just going to rewrite it in the form of a fraction. Okay, so let's use PEMDAS. The P in PEMDAS tells us to work with parentheses first. Within these parentheses, you cannot simplify this any further. These are not like terms, so you cannot subtract them. You cannot put them into, you can subtract them, but that's how they'll stay. It'll be like this minus this. You can't put them into one term. You can't combine them into one term. If this one had a b, then definitely you could. Or if this 4b didn't have the b and it was just 4 minus 1, then you could. But they're not like terms, so for now, parentheses are okay. And even within these bigger parentheses, we could technically simplify if we wanted to, or we could carry out a multiplication by using the distributive property if we wanted to. But after what we just did in the problem before this, you'll see why we don't want to do that. So we've actually factored out, it's already factored out here. Let me show you. All we have to do is cancel out common factors. So there is a 2 times this in the numerator and a 3 times this in the denominator, right? We have 2 times a binomial and then 3 times a binomial down here. So we have this binomial is the exact same as this, and they're common factors, right? So you could cancel them out. So this will cancel out with this. They cancel each other out, and your answer is literally 2/3. That is the answer for this one. Let's look at the next problem. This problem here asks us to simplify the following expression, and then it gives us these here where we have to use a distributive property. So growing up, we always multiplied one thing times something else, right? 2 times 5 is 10. One thing times something else. -7 times +2 is -14, right? And we've known how to do that for a really, really long time. But how do you multiply one thing with two things? So for example, how do you multiply at the top here? How do you multiply this 0.2 with this binomial right here? We do that by using the distributive property. To distribute means to pass out. So that's what we're going to do. We're going to pass this 2 to each term. So we're going to multiply it to that term, and then we're going to multiply it to that term. And we'll do the same thing here. We'll multiply this 3 to that term, then to this term, and this -5 to this term, and then to this term. All right, so that's how we're going to solve the problem, but let's be very specific about this, and let's use PEMDAS, the order of operations. So first order of operations is P, work within the parentheses. Within these parentheses, you cannot simplify it any further. These are not like terms. This B term or -B term is not like with this -7 term, so you cannot combine them. Same thing here. This 6B is not a like term with this -1, so they cannot get any closer or any simpler. That's exactly as simple as it could be. Same thing here. Okay, let's continue to use the order of operations. The next one is exponents. Well, there are no exponents here, so we could skip that. Then there's multiplication. There is multiplication here. We spoke about that. This 0.2 is going to be multiplied to each term. This 3 is going to be multiplied to each term. Then the -0.5 will be multiplied to each term. I'm going to do this in different colors. That way we keep track of what we're multiplying here. So this 0.2 times this -b, that's a positive times a negative, which is a negative. 0.2 times b, you literally just put them next to each other. Remember in math, when two things are next to each other, just like here, this is next to that, it means they're being multiplied. So this being next to the b, it means it's being multiplied with the b. Now let's multiply 0.2 times -7. A positive times a negative is a negative again. 0.2 times 7 is 1.4. And we can continue now. We're going to get this +3 and multiply it to 6b. So a positive times a positive is a positive, so it's going to be positive. I put a plus sign. And now we've got 3 times 6 times b, right? So I'm going to write that down here. It's 3 times 6b, which is really 6 times b. So 3 times 6 is 18. It's going to come out to 18b. So 3 times 6b is 18b. This scratch work that I did down here, I would advise that when you do that, you do it somewhere else so it stays away from the process. You want to keep your process clean. Okay, let's multiply the 3 times the negative 1. Positive times a negative is a negative. 3 times 1 is 3. Okay, we can continue here. Now we're going to distribute the negative 0.5 and multiply that out. Now we're going to distribute this negative 0.5. A negative times a negative is a positive, so we put a plus sign. 0.5 times b is literally 0.5 times b, so 0.5b. 0.5 times positive 2. Negative 0.5 times positive 2 will give us a negative answer. So 0.5 is really 1/2. 1/2 times 2 is 1. So we've done the parentheses. There weren't exponents. We just carried out the multiplication. There's no division. There is addition and subtraction. So remember, those are worked from left to right, whichever one comes first. So now we can combine like terms. We can add and subtract the like terms and put them together to be just one term. And I'm going to draw some arrows so that you can see this process happening. So all of the b terms I am going to put over here. They're all going to be together there. Numbers are like terms with each other. So all of the numbers I am going to put here. We will combine them all into one term right there. All right, let's go ahead and do this. So the b terms, negative 0.2b plus 18b plus 0.5b, that's going to go right here. And you keep that variable and exponent that made them like terms, right? This is b to the first power. If you don't see a 1, or if you don't see an exponent, there's an invisible 1 right there, but you don't have to write it. So we keep the b, and then we add or subtract the coefficients. So negative 0.2 plus 18 plus 0.5 comes out to 18.3. And you can see that easily. Here we have 0.5 minus 0.2, which is 0.3. And then so 0.3 plus 18 is 18.3. Right, so we have 18.3b, that's our b term. And now the numbers, we have negative 1.4 minus 3 minus 1. So these are all negatives. It's going to give us a negative number. If you think about it, if you're on the negative side of a number line and you're subtracting, you're going deeper into the negatives. So this is going to give us a minus something, a negative something. And you can put in your calculator in your mind, you can calculate this. It comes out to negative 5.4. Right, we have negative 3 made more negative by 1, that's negative 4. Minus 1.4, that's negative 5.4. And this is our answer. This problem is very similar to the one before it. The only difference is that we are going to have to determine in which step this person made an error or a mistake. So let's do the exact same thing that we did earlier. We're going to use PEMDAS. Remember, within the parentheses, we cannot simplify these any further. They're not like terms, so we cannot combine them. There are no exponents. There is multiplication, so we can distribute this number and multiply it out to each term within the parentheses. Let's go ahead and do that. Negative 0.1 times x is negative 0.1x. Negative 0.1 times negative 2, that's going to give us a positive, and a positive 0.2. Now we can distribute the next ones. Negative 10 times 3x, that's negative 30x. Negative 10 times negative 5, that's a positive 50. Now let's do the last one. Positive 0.5 times 2x. Well, let's work this out down here. We've got 0.5 times 2 times x, which is 2 times x like that. 0.5 times 2, that's 1/2 times 2. 1/2 of 2 is 1 times x. So that's going to give us a 1x, which is just x. Positive times a positive is a positive, so positive x. And again, if you're doing this on your paper here, keep your scratch work separate from everything else. 0.5 times 1, well, anything times 1 is itself, so that's going to be positive 0.5. Let's look to see if they did step 1 correctly, and they did. You will notice that it looks exactly like step 1. So now let's check their step 2. In step 2, you'll notice that they combined the numbers together. Numbers are like terms with each other. So 0.2 plus 0.5, that's 0.7. And then 0.7 here plus 50, that's 50.7. So this part is correct. They didn't change anything from this part here, so they are correct with that part too. Now let's check step 3. In step 3, they try to combine the terms with the variable x in it. Let's see if they did that correctly. Remember that you would keep the x, you keep that variable and exponent that make them like terms. That's x to the first power. And then you add or subtract the coefficients. So negative 0.1 minus 30 plus 1. So negative 0.1 minus 30, that's negative 30.1. Negative 30.1 plus 1, so now it's going in the positive direction. That's negative 29.1. And they happened to add incorrectly. They should have gotten negative 29.1x plus 50.7. That is what the answer should have been. So this is the step in which an error occurred. The error occurred in step 3. In step 3. This sample problem asks us to simplify the expression 5a plus 9 in terms of b, but they tell us earlier that a equals 3b minus 1. So they give us an expression in terms of a and ask us to simplify it in terms of b. So it says if a equals 3b minus 1, simplify the following expression in terms of b, 5a plus 9. All right. Well, if a equals 3b minus 1, what that means is that anytime you see an a, you could replace it with this, because no matter how different they look, they're equal to each other. So wherever we see an a, we're going to replace it with this. We're going to substitute a with 3b minus 1. So what I'm going to do is I'm going to write this expression here, 5, but instead of writing an a, I'm just going to put parentheses because we're going to replace it with something. So that is 5 times, and this is what a is equal. So I am going to replace a with that. 5 times a plus 9 is 5 times 3b minus 1 plus 9. Okay, so now we could use the order of operations to simplify. Within the parentheses, we can't simplify further. 3b minus 1, they're not like terms. There are no exponents. There is multiplication. Let's carry that out. You use the distributive property to multiply 5 times this binomial, 3b minus 1. 5 times 3b is 15b. 5 times negative 1 is negative 5. We bring down that plus 9 here. All right, let's continue using PEMDAS. There's no division. There is addition and subtraction. We work these from left to right. So first we carry out the subtraction, but these are not like terms, so we cannot combine them. So then we go to addition. These are like terms. We can combine the numbers. So the final answer will be 15b plus 4. 13b plus 4. Negative 5 plus 9 is the same thing as saying 9 minus 5, so that's 4. And this is the answer. I hope you enjoyed this video. The one that follows after this is how to solve algebraic expressions. I will see you there.